finite limits to the simulated world we find ourselves in. And we can go one step further and call this total thing the metacosm and talk about it, but we'll have to get some. And it's Scientific American 2005 says, our universe is but a shadow of a larger reality, is their conclusion from the fact that the constants of the universe we're now discovering are not really constant at all. And Paul Davies, a secular scientist, says, it seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. When they try to build a mathematical model, a three-dimensional model of the universe, they discover there are relationships that cannot be violated or it all falls apart. It's very, very tightly tuned. And they call it's as if it was all designed for mankind. So this concept that they encounter is called by them the anthropic principle. It's as if the universe was designed for man. Let's take a look at it. It's the appearance that the universe was designed in constructing the model we believe that we know about. Of everything we know about the universe, there are hundreds of delicate ratios, if altered in the slightest, would render life impossible. And sometimes it's 1 part in 10 to the 55th, surprisingly enough. As we understand the universe, there are 4 basic forces that are encountered. Gravity we all know about, electromagnetic force we know about, and there's 2 nuclear forces, strong and weak nuclear forces. These 4 forces explain everything that we know about in the universe. Gravity, that's what causes an apple to fall to the ground, keeps our feet on the floor, binds together our solar system, keeps the Earth and the planets in their orbits in effect, prevents the stars from exploding, and guides the galaxies in their motion. That's what gravity is all about. There's another force that operates closer in called electromagnetic force. It holds the atom together. It determines the structure of the orbits of the electrons and therefore all chemistry, governs the laws of chemistry. The forms of electromagnetic force can include X-rays, radio waves, and of course light. And it can overcome gravity on the Earth. So for short distances, it can overcome gravity. And it can dominate other forces down to the size of the nucleus of an atom. There things start to change. That's where we encounter 2 nuclear forces. The strong nuclear force is what binds the protons and neutrons in the nucleus of the atom. The balance between the strong force and the electromagnetic forces limit a nucleus to about 100 protons, and that's what limits basically what we know as the periodic table. The energy release is substantially greater than electromagnetic, that is the chemical forces, and thus that's what causes stars to shine, essential for life and so forth. The weak nuclear force governs atomic instability and radioactivity, the disintegration of heavier nuclei. It can create heat, such as the decay of radioactive elements in the Earth's core, or in a nuclear power plant. So these are 4. Now, the gravitational coupling, if let's just take each one of these. If the gravitational coupling was a little bit stronger, all stars more massive than our sun by about 1.4 times, they burn too rapidly, they too inconstantly to maintain life-supporting conditions on surrounding planets. If it was just a little bit weaker, all stars would have less than 0.8 times the mass of our sun. There would be no heavy elements in the universe. Electromagnetic coupling. If it was a little weaker, the molecules of life would cease to exist. If it was slightly stronger, the molecules for life would cease to exist. It happens to be just at the right amount. The strong nuclear force coupling. If it was slightly weaker, multi-proton nuclei would not hold together. Hydrogen would be the only element in the universe. If it was slightly stronger, nuclear particles tend to bond together more frequently and more firmly. Hydrogen would be very rare in the universe, and the supply of various life-essential elements would be heavier than iron, would be insufficient. The weak force coupling, if it was larger, there'd be no helium, no heavy elements. If it was weaker, everything would be helium, and there'd be an overabundance of heavy elements. The ratio of electron to proton mass, if it was larger, the molecules would not form, life would be impossible. If it was smaller, molecules would not form and life would be impossible. It happens to be just at the amount it has to be. The distance from the sun, if we were closer, it'd be too warm for a stable water cycle. If it was further, it'd be too cold to have one. Surface gravity, if it was stronger, the atmosphere would have too much ammonia and methane. If it was weaker, atmosphere would lose too much water. The thickness of the Earth's crust, if it was too much oxygen if it was thicker, too much oxygen would be transferred from the atmosphere to the crust. If it was thinner, volcanic and tectonic activity would be too great. It's right in an ideal balance. The Earth's rotation period. If it was just a little bit longer, the diurnal temperature differences would be too great. If the days were too short, it would get too hot and too cold, if you will. If it was slightly shorter, the atmospheric wind velocities would be too great. These are all discoveries that are astonishing people to realize how delicate everything seems to be balanced. The axial tilt. If it was greater, the surface temperatures would be too great. And if it was less, the surface temperature would be too great, for different reasons, obviously. And The albedo, that's the reflectivity of the planet. If it was a little greater, a runaway ice age would develop. If it was a little less, a runaway greenhouse effect would develop. It's just at that right balance. The Earth's magnetic field, if it was stronger, the electromagnetic storms would be too severe. If it was weaker, there'd be inadequate protection from the hard stellar radiation. The ozone level, I love this one. If it was greater by just a little bit, surface temperatures would be too low. If it was less, surface temperature would be too high and too much ultraviolet radiation at the surface. But the reason I think this is kind of interesting is the ecologists tell us that, gee, if the ozone level was just a fraction of a percent, a tenth of a percent more or less, it brings cosmic doom. When they say that, turn that coin over. If it's that delicate, who balanced it in the first place? The fact that it's that delicate is an argument that it didn't occur randomly. By the degree it's rare to the degree it excludes randomness as a source. Furthermore, it raises another issue. Not only who balanced it, who is maintaining the balance? If it's that delicate, it would be intrinsically unstable unless there were countervailing factors involved. CO2 and water vapor. If it was greater, runaway greenhouse effect would develop, and if it was less, the greenhouse effect would be insufficient. So, at the atomic and subatomic level, the slightest variation in any of the primary constants of physics, some is less than 1 part in a million, causes life to be impossible. And that's just a reality. The more rare these relationships are, the more they unequivocally reveal both skillful design in their origin and diligence in their maintenance. That's something that's often overlooked. They have to be maintained. You know, the ancient cultures created false gods of wood, stone, whatever, to worship. Our cultures invented the most insulting God of all that we choose to worship. Randomness, the total absence of information. We've chosen to worship the absence of information. Ignorance, strangely enough. Of all the gods, false gods that man has worshipped, this one, the one we embrace in our culture, is the most insulting of all. In 1954, Sir Fred Hoyle, a scientist, predicted using the anthropic principle and then discovered the previously unknown energy of levels in the carbon-12 atom from its sensitivity to the prevalent patterns of numerical design in the universe. Very interesting event because he used the anthropic principle predictively. They were struggling with a carbon-12 issue, and he predicted a level of energy that they then tooled up and discovered was there. But he predicted it in advance of its discovery by applying the anthropic principle, a very, very interesting event from the point of view of science. You're going to hear more and more a term called the privileged planet, because not only is this planet that we live in uniquely positioned for life, as they study the universe and its billions and billions of galaxies and the number of planets that might be around those stars, they discover the offset is the rarity of the conditions for life are so rare that it still doesn't, it comes to the conclusion that we are unique in the universe, strangely enough. But we are also not only uniquely positioned for life, they've discovered something else. We're uniquely positioned to discover. The fact that you can have this first occurred to some scientists, they were watching the eclipse of the sun. The moon is exactly the right size and the right distance to create a total eclipse. If it was a little bit bigger, a little bit smaller, you would not be able to see the corona. And by being able to see the corona, they were able to analyze it and discover not only what the sun is made out of, but by discovering that spectroanalysis, they can tell what other stars are made out of. But they also discovered it was as if it was tuned, not just for life, it's tuned to allow us to discover. As they begin to analyze our position in our galaxy, we're not too close or too far from the center to be able to see the rest of the universe. And just as we have an array of tuning that's gone on here to make life possible, we also are discovering there's an array of issues, dozens of them, that have been tuned to allow us the opportunity to discover. The fact that our eyes are sensitive to the visible, a very, very small part of the electromagnetic spectrum, but it's that very part of the spectrum that allows us to discover the universe itself. It says not only are we placed here as a beneficiary of life, we're also placed here as a beneficiary of the opportunity to discover.